Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2025. Now this paper is 1 hour 15 minutes long and it has 6 questions and it's a total out of 70 marks. Question number 1 is on the topic of forces. In a dog's sled race, a team of dogs pull on the rope attached to a sled. So you have a picture of the dogs pulling the sled and the rope, all three labeled. Use the physics equation sheet to answer questions 1.1 and 1.2. What equation links distance traveled, speed and time? Now you know that the equation that links all three of them is the speed equation. Speed equals distance divided by the time. Now you look at this option, speed equals distance time multiplied by distance traveled. That is incorrect, which means you will have to rearrange to find the right answer. Let's try the first one. If we rearrange this, speed multiplied by the time is equal to the distance. That's correct. For those of you who would use the equation triangle, remember speed, distance and time. So you want to find out the distance, it's speed multiplied by the time. So this is the correct answer. Let's change the color. Right. And the next question, 1.2, the longest dog sled race in the world covers a distance of 1,500,000 meters. That's the distance. One team finished the race at a time of 670,000 seconds. Calculate the average speed. So the average speed, still speed equals distance divided by the time. 1,500,000, divide that by 670,000. That would give you an answer of 2.2 meters per second. 2.2 meters per second. The answer. Next question. At the start of the race, 6 dogs pulled on the rope. The average forward force on the sled from each dog was 370 newtons. So this from each dog. The backward force on the sled from friction was 520 newtons. Calculate the resultant force. Now, if I was to draw a really simple diagram to show this, let's say that's my sled. It's going to look like that. And that's pulled by 6 dogs. So let's say 1, 2, 3, 4, 5, 6 dogs. Now they're saying the force from each dog, force from each dog is 370 newton. So the total forward force has to be multiplied by 6 to give you the total forward force. Now the backward force is 520 newtons. So the resultant force, RF, let's say, now let's put capital F, is equal to 370 times 6. Put that in brackets and take away 520. Now that would give you an answer of 1,700 newtons. That's 1,700 newtons. Go back to purple. Right. Next question. Figure 2 shows a distance time graph for the sled at the start of the race. It's a line graph where the line is actually going up, or it's showing positive gradient. what does the gradient of the graph in figure 2 represent? Now remember, the gradient of the graph, of any graph, gradient is equal to the y-axis value divided by the x-axis. Here, the y-axis value is the distance in meters, and the x-axis is the time. So if I divide the distance by the time, I would get speed. Distance divided by the time, that's a speed. So what is the gradient of the graph? Speed is the gradient. Next question. Later in the race, the sled moved at a constant speed along a flat horizontal path. What was the relationship between the size of the horizontal force acting when the sled moved at a constant speed? Now, if something is moving at constant speed, the resultant force should be 0. So force would be 0. That's Newton's first law. Right? For that to happen, the forward force, which is the pull from the rope, right? That's the forward force, should be equal to the backward force. The backward force is the friction and the air resistance. The forward force is the pull on the rope, of the rope on the sled. So the option is, which is second option, because that's the one which says equal to. The rope exerted a force on the sled when the sled was moving. What is the Newton's third law pair to the force of the rope on the sled? Newton's third law says this: for every action there's an equal and opposite reaction. So pair to the force of the rope on the sled. And if there's a force of the rope on the sled, then the force of the sled on the rope is the exact opposite. That's the third option. That brings us to the end of question number 1, and I will see you in question number